Hi there! Previously we discussed the options to monitor unstructured data quality and data drift, specifically for text. Now I would like to cover a topic of monitoring multimodal datasets. Quite often we do not just work with unstructured data or structured data. There are a lot of applications where we have combinations of both, some unstructured data, for example text, and some structured data like numerical or categorical values. For example, if we need to perform some analysis on top of product reviews, of course we have some unstructured data, which is the text of those reviews, which were manually written by some customers, and we have some metadata which are structured, like maybe the region, like device the user used to create a review, maybe the type of product or category of user. So both of structured and unstructured data have quite a lot of signal, and if we build a model, we need to take into account both signals from structured and unstructured data. There are quite a lot of such applications where we deal with multimodal datasets, like chats plus metadata, maybe some support ticket to help centers where we have a lot of metadata, like again user region, device, type of problem, and the text of the review or the question or the complaint, right? We have some emails and etc. So we need to be able to deal with multimodal data. I would like to present to you three pretty straightforward approaches to monitor multimodal dataset. The first strategy is just split your data by type and monitor them independently. Second strategy is turn unstructured data into structured and apply the approach for monitoring structured data. And finally, third strategy to learn how to deal with unstructured data. Let's dive in. So first strategy is very straightforward. Imagine you have a multimodal data set where you have some structured data and, for example, text. In this case, you can basically split this data set into two and independently build your monitoring for structured data, like some descriptive statistics, maybe share of missing values, distribution drift, correlation changes, etc. And just add to the same monitoring dashboard some panels which you build on top of your text data. For example, raw text data analysis, embedding monitoring, etc. So you'll have the unified dashboard, but the panels you include in those dashboards will be built on top of different parts of your dataset. That's pretty straightforward. The second strategy is actually based on the descriptors. So if you have an unstructured data, for example text, you can come up with a lot of meaningful descriptors which describe the properties of your text. And as soon as you moved from the raw text to descriptors, you already have a structured data, right? Why not to join this structured representation of text with the metadata you have in your dataset? Basically, if you join your structured features with the raw text-based descriptors, you already have a structured representation, right? And here you can perform some combined analysis of your structured data, like descriptive statistics, missing value statistics, drift analysis, and etc. That's quite convenient because after a join, you deal with a single structured data. Finally, quite often we deal with embeddings, and we can have a combination of embeddings and some meaningful structured data. Here I would suggest to take a look at this problem from a little bit the other angle. We know that embedding is just a vector in some high-dimensional space. Let's assume you have 64 size of embeddings. In this case, each embedding is just a point or a vector in this high-dimensional space, right? What if you also have three structured features? For example, region, device type, and product category. So all those features are numerical, and basically if you just join those features with the embeddings, then instead of 64 dimension space, you will have 67 dimension space. So basically if you join your structured data with embeddings, you just expand the size of your space where you have your objects. So basically after you perform this join, you can use any methods to detect, for example, embeddings drift, like share of drifted components, or maybe domain classifier, or some distance-based metric. To sum up, we discussed at least three different strategies to deal with multimodal data. Previously, we discussed our options to work with raw, unstructured data, specifically text. So, if you do have access to the raw text data, do not ignore it because interpretability wins. If you perform the evaluations of metrics on top of the raw text data, then in most cases you would be able to get a deep understanding of what exactly has changed and what is the problem with your text. So, it's very nice to have. If you're dealing with embeddings, do not get upset because there are quite a lot of methods to detect drift in embeddings as well. And if you have multimodal datasets, you already know what to do. Either split your data into two types or use text descriptors and then come up with the structured data representation for your multimodal datasets, or deal with embeddings.